numbers on a paper.
The ratio test, friends, is one of those frequently used methods to test if a series converge or diverge. So guys, in all my years as a calculus and a science teacher, guys, I have been frequently using the ratio test most always compared to other methods of testing whether a series converge or diverge. So guys, in this video today, we shall be looking at a qualitative study of the ratio test. At the end of this video, guys, you shall understand the concept entirely. So guys, my name is Umenju Macarius, and this is Humble Mark Academy, where I take complex science concepts that students find it very difficult to understand. I break them down into tiny pieces so that any student across the globe watching me can use this understanding now to score a better mark, if not, guys, the best of A grade in his or her exams. In exchange, guys, all you need to do is to hit that subscribe button looking at you, because I can only help you to pass your exams once you subscribe to my channel, guys, and turn on your notification icon to get notified, so that each time I upload a video, you'll be the first person to get notified. Great. So guys, please give the video a thumbs up, like the video, share it out, place your worries in the comment section below, guys. That also motivates me. It also tells me that you're actually following how I'm making the videos. Great. So guys, let's get started. Great, friends. All right. So friends, now suppose that we have a series such as a series as n goes from k to infinity of a n, guys. According to the ratio test now, friends, if the limit or the absolute value, guys, of the limit as n goes to infinity of a n plus 1 over a n, guys, if we have some value, we can call that value L. Case number 1, guys, if our L is less than 1, then, guys, the series as n goes from k to infinity of a n, guys, is convergent or it converges. Then now, guys, if our L is greater than 1, then, guys, the series as n goes from k to infinity, guys, is divergent or it diverges. And friends, most importantly, take note, guys, most importantly, if L is equal to 1, then the ratio test is inconclusive. Namely, guys, the ratio test has nothing to say about the divergence or the convergence of that series. Great. Very important, guys, very important. Keep in mind that the ratio test is mostly used to test for positive series, okay? Positive series. That's why if you suspect that the series might be negative, then it will be very important to take the absolute values. But once you recognize that the series is positive, no need for the absolute values. Great. So guys, this is what the ratio test is saying. When L is less than 1, it is convergent. When L is greater than 1, it is divergent. When L is equal to 1, guys, the test has nothing to say about the divergence or the convergence of that series. Great. So guys, let's look at an example. Let's look at an example, guys. I think we should look at let's just look at one example, then I can give the other as an assignment. Let's test whether the following series below converge or diverge. All right, that's what we have. You have another. Great. So guys, I shall give you this as an assignment, okay? But I'm going to do this. All right. So now, guys, to test if this our series converge or diverge, let's have a solution. And the series, that's it, from n equals to 1 to infinity of n raised to the power n over n factorial. So guys, let me give you guys an important hint. Questions of such will not tell you the method to use, okay? They won't tell you the method to use. But friends, for the ratio test, an important hint: whenever you see a factorial guy, right, go ahead to give the ratio test a try, okay? Great. Whenever you see a factorial guy, go ahead and give the ratio test a try. All right. So guys, in such a case, we are going to take as the definition suggests, and we can see that the series in this case is positive, right, in the interval from 2 to infinity, right? So it is positive. So we don't need the absolute value. So in this case, guys, we're going to be looking at the limit as n goes to infinity of our an plus 1, guys, is simply going to be n. Anywhere we see n, we just replace it with n plus 1. So we have n plus 1 raised to the power n plus 1 over n plus 1 factorial divided by an dividing it by an, which is the same sequence, is simply the same like multiplying by the reciprocal, right? That's what we have here. So guys, we know how the factorial behaves, right? Great. And we can use indices now to split the top. That therefore implies we are going to have n plus 1 raised to the power n. Like I said, we are going to use indices, so we are going to have n plus 1 raised to the power 1. All that over the factorial guy, we are going to have n plus 1. Keep in mind that we are stepping down by 1, so we are going to have the next guy, which is what is in the bracket minus 1, still in the factorial. So n plus 1 minus 1 is simply what? N. So we have the factorial multiply with n factorial over n raised to the power n. But first, we see that n plus 1 up can cancel with n plus 1 down, right? Likewise, n factorial down can cancel with n factorial up. Great. At the end result, now we are going to be looking at the limit as n goes to infinity of just n plus 1 raised to the power n all over this, our uncancelled n here. So we have this. Great. So guys, we can, since all of them, since both the top and bottom have been raised to the power n, right, we can simply couple them together. We are going to have the limit as n goes to infinity of just n plus 1 over n, all that raised to the power n. Great. So guys, the interior of this our fraction, we can simply split them down. So we are going to have n over n plus 1 over n. So n over n, guys, simply 1. So we have 1 plus 1 over n, all that raised to the power n. So guys, do you recognize this our series? Do you recognize this limit, guys? Great. It simply has the famous value we have, right? Namely that imaginary number, that number e, right? Great. It gives us e. This is just the limit, right? Okay, this is the limit, guys, and this is the fact. Great. So guys, when we say e does not do us any good, right? Wait, when we leave our answer like this, our teachers are going to be very mad at us. By so doing, guys, we must tell them that e is what? Greater, is approximately the same like 2.7183, right? If you don't know the value, right, is about 2.7183 to 4 decimal place. And we must tell them most importantly that word, guys, that e is greater than 1, right? And guys, based on our conclusion, right, if L is greater than 1, that therefore implies the series is divergent, right? So we can come back and say that the series as n goes from 1 to infinity of n raised to the power n over n factorial, guys, does what? Diverges by the ratio test. Great. So guys, I hope you found the video useful, guys. I hope you understand, guys. If you didn't understand, guys, please let me know in the comment section below, guys. I'm going to get back to you as soon as possible. And friends, before you go, hit that subscribe button so that you won't miss on any of our interesting great contents. Great. So guys, like the video, guys, give it a thumbs up, share it out with your friends so they can have access to important and great content like this. Like I said, guys, please do this at home, okay? Please do this in your spare time, and let me know in the comment section down below if it converges or diverges, okay? Just let me know. If it diverges, simply write sir, diverges. If it converges, simply write converges or convergent. Great. So guys, that's it for our video, guys. Have a blessed day.